Dear students, so let me illustrate how to imagine the geometry of an unit cell. So the atom or molecule or ions are usually spherical in shape. So let me demonstrate with the available fruit. So let it be an atom. So this is one atom. This is the second atom, the third one, the fourth one. I think you will be able to imagine this. So four atoms are in a regular shape. So if I put a boundary, what shape we get? Yes, you are getting a square. So in 3 dimension means we have four more atoms. So the next one, next one, next one, and next one. So now I have 8 pieces of atoms assumed. So these 8 are arranged in a regular pattern. So in what geometry can be assumed? So if you observe this structure from the top angle, and if you put a boundary, you can see the square. And the same way, if you look from the bottom, same square. Look from the front, or look from the back, or look from the right side, or look from the left side, all squares. If 6 squares are joined in this way, what geometry, what shape you will get? Can you imagine? Yes, we get a cubic shape. So in the cube, let's say let it be this a cubic shape. I don't have a cube here. We can imagine this as a cube. So in the cube, this is one atom. This is x-axis. This is y-axis. This is z-axis. X, Y, Z. This distance A, this distance B, this distance C, and this angle, this angle, this angle, alpha, beta, now. In this cubic, or in this arrangement, if you observe the distance, the A, that is this distance, and this distance are the same. That is A equal to B, B equal to A equal to B, B equal to C. So all are same. Similarly, if you observe the angle, so this angle 90 degree, this angle 90 degree, all angles are 90 degree. That means all the angles are 90 degree. Alpha equal to beta equal to gamma, all 90 degree. So if 8 atoms are arranged, like this, we get a cubic arrangement. It is not cube, but it looks like a cube. This is one unit cell. In a particular crystal, if I go on arranging the fruits like this in the x-axis, y-axis, and z-axis, imagine thousands and thousands of fruits are arranged like this, we get a crystal structure. So that if 1,000 fruits are arranged like that, if you look into that, that is called the crystal lattice. If you observe only this portion, it is called the unit cell. So the same pattern is repeated in 3 dimension x, y, z axis that constitute the crystal lattice. So if we observe in the crystal lattice the edge length and interfacial angle, we can decide the shape or geometry of the unit cell by observing these angle and these edges. Crystallographers found the crystals contain 7 types of unit cells. 7 types. The model that I showed is cubic. This is one unit cell, cubic. So in cubic unit cell, its length ABC are equal. The interfacial angle alpha equal to beta equal to gamma equal to 90 degree. This gives cubic shape. The other 7, totally there are 7 types. The other 6 are namely cubic, tetragonal, hexagonal, orthorhombic, monoclinic, triclinic, and rhombohedral. So these are the 7 types of unit cells found in different crystals. Let me repeat the names: cubic, tetragonal, hexagonal, orthorhombic, monoclinic, triclinic, rhombohedral. How they differ? Only in these parameters. You can observe these geometries in your textbook. I'll try to show in the next session the geometries of these cubic unit cells. So in these are the 7 types of unit cells found in different crystals. We are going to focus only on the cubic unit cell in our unit. So let me represent the cubic unit cell like this. So you can consider a cube. You can draw a cube like this, one square, next square. If you join the ends, you get a cube. You can assume this is one atom, second atom, third atom, fourth atom, fifth atom, sixth atom, seventh atom, eighth atom. But don't think this way the atoms are present. I showed the fruits as model. They are closely arranged. But in order to imagine the shape, I have drawn like this. So this is called the cubic arrangement. So here atoms are present only at the corners of the shape. If atoms are present only at one, this is called a lattice point. Each one is called a lattice point. Only one lattice point if present in the unit cell, it is called the primitive unit cell. So there are some modifications in the primitive unit cell. So I am going to represent another cubic unit cell. So here we have 1, 2, 3, 4, 5, 6, 7, 8 corners. One atom may be present here at the middle of the unit cell. This is called the body-centered cubic. This is called the simple cubic. So here there is additional lattice point. This is original, in which atoms are present only at the corners. This is called the primitive. Along with the corners, if atoms are present at the middle or at the faces, they are called the non-primitive unit cell. So unit cells are 7 types. These are the names. In the 7 type, we can classify them into 2 types, namely primitive and non-primitive. Travis found that there are about 14 types of unit cells in different crystals. So this is about the unit cell, crystal lattice and coordination number.